Good evening, everybody. So tonight we will discuss about sample problem of autocycle. This is coverage. This is our preliminary exam. So we already write the. I drawn the PV diagram and PV diagram. So uh, in this in process 2 4, this is the constant volume heat addition. In the process 4 to 1, there is the constant volume heat rejection. So we also drawn I will also drawn the TS diagram. So as stated in the problem, our compression compression ratio is equal to 9.5. Our pressure 1 is 100 kilopascal. Temperature is 35 Celsius. So 35 Celsius, to make it absolute, we will add 273 to make 308 Kelvin. And our volume 1 is stated in the problem is 600 cubic centimeter. So we will make it to cubic meter. So the new equivalent of our volume 1 is equal to 3 over 5,000 cubic meter. So also stated in the problem, after the is isentropic expansion, so it means it is the temperature for which is 800 Kelvin, and Cp is equal to 1.0047 kilojoule per kilogram Kelvin. Specific heat constant volume specific heat constant volume is equal to 0.7176 kilojoule per kilogram Kelvin, and R is 2.87 kilojoule per kilogram Kelvin. So at room temperature, so we will make it as our constant. So in the problem, we will look for the higher temperature and the higher pressure. So it means higher pressure T3, P3, pressure 3, and higher temperature is equal as T3. So first, so in our state 1, we have a complete given. We have already a complete data. So we will proceed to state 2. At state 2, so T2 is equal to T1, volume 1 over volume 2 is as we know, volume 1 over volume 2 is our compression ratio. So we will change it to compression ratio RK raised to K minus 1. So T1 is equal to 308 times 9.5, which is our compression ratio. I will add the K 1.4. 1.4 minus 1. So as we solve this, wait, where's my calculator? So we will solve it there to 8 times 9.5 raised to 0.4. So we will have an answer of 757.94 Kelvin. So we have already the temperature 2. So now we will proceed to pressure 2. So as the relationship P2 B2 over T2 is equal to P1 B1 over T1. So in this, so as we transpose this equation, we will have RK times T2 over T1 times T1. So 9.5 times T2, 757.94 over T1, which is 308, times the pressure one, which is 100 kilopascal. So as we solve this, 9.5 times 757 over 308 times 100. So we will have answer of 2,337.83 kilopascal. So there. So now we will proceed to state 3 at state 3. So state 3. So T3 equal to T4 times B1 over B2, which is our compression ratio, K minus 1. So T4, which is 800, is stated in the problem, 800 kilopascal times 9.5 times raised to 0.4. So now 800 times 9.5 raised to 0.4. So we will have answer of 1968.69 degrees Kelvin. So this is our highest temperature, T3, which is state according to our graph. So now we will proceed to the we will look for the pressure 3. So relationship P3 B3 over T3 is equal to P2 B2 T2. So according in the to our equation, B2 is equal to B3. So we will cancel this. So now P3 times P2 T3 over T2. None. So substituting P2, which is 2337.83 times T3, which is 1968.69 over T2, which is 757.94. So solving this equation to 2337.83 times 1968.69 over 757.94. So there, we will have answer of 6,072.33 kilopascal. So we already come up with the highest pressure. So now we already accomplished the one question. So now we will look for the efficiency. efficiency is equal to work net over Q added. And so Q added MCB delta T. So our mass, we don't as I solved lately, our mass is 6.788 times 10 raised to 4 negative 4 kilogram. So there, 6.788 times CB, which is 0.7178 76, times the change in temperature, wait, I will look for the problem. As this T3 minus T2. So T3 minus T2, T3, where's our T3? There, 1068.69 minus T2, which is 757.94. So solving this, (6.788) times 10 raised to negative 4 times 0.7176 times 1968.69 minus 757.94. So then we'll have answer of 0.5898 kilojoule. So next, we will have the heat rejected MCB. We will use CB because it is constant volume. MCB T1 minus T4. So substituting 6.788 times 10 raised to negative 4 times CB 0.7176 times T1, which is 308, minus T4, which is 800. So we will have answer of, okay, we will calculate 6.788 times 10 raised to negative 4 times 0.7176 times 308 minus 800. So we will have an answer of 0.2397 kilojoule. So as we know, work net is equal to Q added minus Q rejected. So 0.5898 kilojoule minus 2.2397. So we will have a work net of 0.3501 kilojoule. So we will now solve the efficiency. efficiency is equal to work net over Q added. So 0.3501 over our Q added 0.5898. Solving to our calculator, 0.3501 over 3501 over 5.5898. So we will have answer of 0.5936 times 100% is equal to 59.36%. So our efficiency is 59.36%. So next is the mean effective pressure. Mean effective pressure is work net over B1 minus B2. So B1 minus B2, as we know, B1 over B2 is equal to RK. So solving 9.5 is equal to B1, which is 3 over 5,000 cubic meter over B2. So solving this, 9.5 equals 3 over 5,000 over X. So we will have 6.316 cubic meter. Work net is equal to 0.3501 over B1, 3,500, 5,000, 3 over 5,000 minus 6.316. So solving 0.3501, 3 over 5,000 minus the answer. So we will have answer of 652.15 kilopascal. So that ends our solving prelims Jerome Barcelona BSME 5. So as we summarize, our highest temperature is equal to 1968.69. Our highest pressure is equal to 6072.33 kilopascal. Our work is equal to 0.3501 kilojoule. Our efficiency is equal to 59.36, and and our mean effective pressure is equal to 652.15 kilopascal. So that ends the discussion.